Okay, so this is the introduction to cylinders. Now, cylinders are kind of just like prisms, except they have circular bases instead of polygonal bases. So, the technical definition is um, basically what I just said. The line connecting the centers of the bases is called the axes or axis. So in this diagram, O to O prime is the axis of the cylinder. And the radius of a base is the same as the radius of the cylinder itself. So now that we have some terminology, let's go ahead and discuss some more common terms. If the axis is perpendicular to the base, then you have a right cylinder, which is the cylinder shown here in figure 15.1, where they make a perpendicular or right angle. And we would just call that a right circular cylinder. But then we have these weird cylinders on the bottom in 15.2. We're not going to really work with those ones so much, but they're good. We should be aware of them. All right, so what's our first problem? Suppose we take a cross section of a cylinder that is perpendicular to the axis of the cylinder. What shape is this cross section? If you can remember, a cross section is when you have a plane sort of cutting your three-dimensional object into some shape. So now it's tough to really draw a cylinder even in 3D space, so I'm just going to get an object that somewhat looks like a cylinder. Where would that be at? What is our cylinder object? This pot. I mean, this is fairly close to a cylinder. It's got two circular bases and the edge around it. So, I mean, you can think like a Pringles can is a cylinder and all that. So let's use this as our cylinder. Nice real world example. And let's make the cross section in the way that they're talking about. So the cross section of a cylinder that is perpendicular to the axis. Remember, the axis is the point of the cylinder from the top to the bottom. So it would be like a line like from here to there. Now, perpendicular to that, well, I'll actually just draw the axis. So the axis is going to be something like that, where we can imagine this circular part is its own figure, really. So from one base to the center of the other. All right, now let's make a plane that's going to make a cross section perpendicular to that axis. So what is that going to look like? Perpendicular means forming a 90-degree angle. So I want to draw the plane such that if it were to cross through, it would be at a 90-degree angle. So something like that. And now to imagine what the cross section looks like, let's fill in the plane in the areas outside of the cylinder itself. Because that intersection is what the cross section we're really looking at. So now that we've drawn the plane, the cross section is the part that's going to be left out, the part blocked off by the cylinder. In reality, it's more like the section that is actually in the inside, but we're not going to worry about that too much. So if we remove the pot, and let's get rid of, I will leave it. I mean, as you can see, the outline is a circle itself. So we would say, I'm going to color in green, that all this stuff here is the cross section of the plane and the cylinder. All that space there. And that space is forming a circle. If we were to go back and look at the cross section itself is the green area, the plane is the red area going through it, and the cross section is a circle, a two-dimensional circle. So with that being done, let's move on to the other parts. Okay, so part B, what is the shape of a cross-section of a cylinder that contains the axis? So this is a little interesting. And again, the axis is straight through the middle, top, up, and down. So let's draw a plane that would encompass that axis. That would look something like this. And again, let's highlight the parts on the outside of the cylinder. Just like this. And what shape are we going to be left with on the inside if we're to cut through? Well, let's remove the cylinder, and what do you know? It's a rectangle. So this rectangular section is the cross section of the plane going through the axis of the cylinder. And if we put the cylinder back where it was, we can see sort of this cross section in real time. So let's adjust. We can see that it's going through and it's making this rectangular object as the plane cuts through down the middle. So part B, your cross section is a rectangle. Now, what is the shape that is parallel of what is the cross section of the cylinder parallel to the axis of the cylinder? So it's going to be, let's look at our cylinder. Now our axis is directly in the middle, so that would be something like, again, like a line like this. So let's draw a plane that's parallel to that, so not touching, but going in the same direction. So something kind of like this. And that should be good. Now let's fill in the plane. And what sort of shape do we have left over? Well, removing this stuff, it seems to still be a rectangle. So we can fill that in. And Again, if we put the plane somewhat off center, you can still see that when the plane cuts through parallel to the axis, right around where this would be, it's still parallel, but it's making this rectangular green cross section still. So that two-dimensional shape where if the plane were to cut through the cylinder is a rectangle for part C as well, just a smaller rectangle. And that is the basic gist.